The India-Asia collision is one of the most significant tectonic events that shaped the Earth in the Cenozoic era. Millions of years ago, the Indian tectonic plate collided with the Asian plate, resulting in the formation of the Himalayas and other geological structures. The key question is how large Greater India is. A portion of the Indian plate subducted under Asia, forming the Tibetan Plateau. Understanding the original extent of this lost landmass is crucial to define the kinematics of the India-Asia collision and shed light on the formation of the Tibetan Plateau. However, convergent evidence regarding the age and paleomagnetic record of the Sangdanlan section in southern Tibet, which was part of the region known as Greater India and which now lies between the Indian and Asian plates, has made this challenging. Now, in a recent study published in PNAS, researchers from China University of Geosciences, Beijing, Ludwig Maximilians University, Chinese Academy of Sciences, and South China Sea Institute of Oceanology have resolved several key questions surrounding the age of the India-Asia collision through a combined radiolarian stratigraphic, structural geologic, and paleomagnetic study of the Sangdanlan section. They recognize Sangdanlan as a highly tectonized region where Cretaceous and Paleocene rocks got mixed by complex faulting. The paleomagnetism of Cretaceous rocks enabled them to track the geographical position of the northern sector of the Indian plate through time and estimate a minimum size for Greater India. The researcher suggests that the lithosphere consumed by subduction since the onset of the collision 55 million years ago was larger than the Indian subcontinent today, originally extending 2,000 to 3,000 kilometers to its north. Consequently, almost 5 million square kilometers of buoyant material has been subducted under the Asian plate, which most certainly contributed to the rise of the Tibetan Plateau in the Cenozoic. The study strengthens the argument for a large Greater India and a contiguous plate in the Neotithys Ocean, the oceanic basin at the leading edge of India. This effectively rules out models that posit a Neotithys Ocean divided into multiple plates, which successively accreted to the southern margin of the Tibetan Plateau.